Hello and welcome to this short presentation on my doctoral thesis with the working title Interfaces for the Internet of Bio-Nano-Things. We start with what is a bio-nano-thing. You can imagine it as, for example, an artificially engineered bacteria that is capable of doing tasks within the human body. Typical tasks would be, for example, collecting data like vital parameters or processing these data and then reacting to them. But we have to keep in mind that these devices need to be very small to swim, for example, in the human blood, pass through the artery system, and so on. In order for them to be so small, they can also only have limited computational capabilities. In order to deal with this limitation, the natural idea is to connect these devices to the internet. The question is, how do we do that? The first thing that we have to keep in mind is that it is not possible to communicate using electromagnetic waves within the human body due to some physical limitations. So what we do is typically molecular communication. So we use molecules to transmit these informations from the nanomachines to the surrounding world and also from the surrounding world to the nanomachines. And my research actually is more or less covering this entire field. So I'm dealing with the topic, how do we get information that was transmitted using electromagnetic waves into the human body? It turns out that we typically do this with injection pumps to encode some information, for example, in the salinity. Then, how does this information spread through the human body? This is then the typical term of molecular communication. How can we engineer these bacteria in order to be capable of performing these tasks that they're supposed to do, which is also something that we're working on. And finally, when these nanomachines have responded to a stimulus or have performed a task, how do we get the information that they try to communicate to us out of the human body? This is again the topic of an interface, and in that case, we want to have an interface from the biological world to the electrical world. And here again we showed that this can be done, for example, by salinity transmission. So if the cells manage to encode this information into the salinity of, for example, the blood, then we will be able to recover the information by salinity measurement. So summing up, what I'm doing in my doctoral thesis is an interface for molecular communication, like from the surrounding world to the molecular domain, computational units in the human body, and how to get the information out of the human body again.